In this video, we want to talk about sequences. Now, before we get into a definition of what is a sequence and some of the terms and notation, let's just kind of look at what a sequence is. It's kind of a general idea. And the idea in a sequence is you have these numbers that are arranged in order. So what we want to do here is just try to determine what's the next term in each of these sequences. So what we need to do is determine what's the pattern. What's the next term? So I'll give you a second. You can pause the video and you can try to determine what is the next term in each of these 6 sequences. All right, let's try these. The first one, 1, 4, 7, 10. We determined we can get our next term by adding 3, so our next term is 13. This is known as an arithmetic sequence, and we'll talk about these later, where we add to get the next term. 1, 3, 9, 27. Our next term is geometric. We multiply to get our next term. 1, 1, 0, 1, 1, 0, 1. That's just a pattern. There's really no name for that. It's just trying to recognize the pattern. If we have 3, 4, 7, 12, 19, 28, recognizing our pattern, the next one would be 39. I add 1, I add 3, I add 5, I add 7, I add 9, I add 11. And if you see that pattern, bells and whistles kind of go off in your head of what that is, what that means. We'll talk about that later. That's a very special type of sequence also. 18, 8, 20, 29. What's our pattern? What's our formula? The answer is 12. Now, how do I determine 12? These numbers are actually the birthdays in my family. I am born on the 18th. My wife is born on the 8th. My daughter is born on the 20th. My son is born on the 29th. And my youngest son is born on the 12th. So really no mathematical formula or computation to get that at all. But I show that just to show you that a sequence is just a number of numbers or numbers arranged in a particular order. So that counts as a sequence. There's no way you would know that unless you knew the birthdays of everybody in my family. And the last one, 1, 2, 3, 5, and 8. Now many times you see the sequence, it actually starts with 1, 1, 2, 3, 5, and 8. And the next number is 13. This is known as Fibonacci sequence, where 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. 13 plus 21 is 34, and so forth. Very famous sequence, Fibonacci sequence, a lot of different places that comes up and is talked about. So these are all examples of different types of sequence. And many times we define the type of sequence by how we get the next term. So a sequence, a set of numbers called terms that are arranged in a particular order. So 1, 4, 7, 10, 13, dot, 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 goes on forever. It's an arithmetic sequence. And then my example of the dates for my family's birthday is an example of something that is also a sequence. Now let's look at some notation. When we talk about these terms of a sequence, we're going to have this notation. T sub 1 represents my first term. T sub 2 represents my second term. T sub 3, my third term. T sub n, we say, is my nth term. So this is just a shorthand notation when we say, well, what's the first term? What's the second term? And so forth. This n here usually represents positive integers starting at 1. So we have this n, and usually it starts at 1, 2, 3, 4, dot, 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 however high it goes up to maybe n. Sometimes it may keep going. to infinity. So let's look at a formula. Here's a formula for our sequence. T sub n equals 4n minus 1. This will be given to you, or you may have to find it depending which way the problem is going. So, we want to find t sub 1. Well, I'm replacing this 1 for this n. So instead of 4n, I have 4 times 1 minus 1. If it's the second term, t sub 2, it's 4 times 2 minus 1. If it's t sub 3, it's 4 times 3 minus 1. If it's t sub 4, it's 4 times 4 minus 1. Now if I evaluate these, I would get 3, 5, 11, and 15. Okay. No, I wouldn't. Let's try that again. This one should be 7. There we go. And so what I have done is to get my next term, I add 4. To get my next term, I add 4. To get my next term, I add 4. This type of sequence is going to be known as an arithmetic. And these are the two types of sequences we're going to look at. Arithmetic and geometric. This idea where I add the same number each time is known as a arithmetic sequence. Now, we word that a little differently in the definition. A sequence where the difference of any two consecutive terms is constant. So how that works is this. If I have this sequence, 2, 6, 10, 14, if I take 14 minus 10, I get a difference of 4. If I take 10 minus 6, I get a difference of 4. If I take 6 minus 2, I get a difference of 4. So it's important that you think about it in that way. For example, let's look at the next one. I have 2 minus 7, 7 minus 12, 12 minus 17. So here my difference is negative 5. And you may think, well, I just think of that as subtracting 5. That will work. But as we look at some formulas, having that d as negative 5 will become very, very important. You know, back here, my difference is 4. I added 4 to get the next term. Now, a geometric sequence is where the ratio of any two terms is constant, and this is where we multiply. So arithmetic, you're adding to get the next term. Geometric, you're multiplying. But just like you add to get the next term in geometric, so you subtract to determine your difference. For geometric, you're multiplying to get the next term, so we divide to find our difference. We would have 64 divided by 16. 16 divided by 4. 4 divided by 1. So this first sequence, my ratio is 4. If we look at the next one, and I do the same type of thing. I take negative 3 divided by 9. 9 divided by negative 27. 80, negative 27 divided by 81. You can see my r is going to be negative 1/3. Once again, I don't want to say, well, I divide by negative 3. You want to phrase it as, what am I multiplying by? For geometric. Just like in arithmetic, what am I adding? What am I multiplying by? Now, this can be harder depending on what we're multiplying by. Here, I have 27 divided by 18. 18 divided by 12. 12 divided by 8. Now, to try to figure out what am I multiplying by, if I factor out a 4, I get reduce the fraction, this would be 3 halves. So I'm multiplying here by 3 halves, or 1.5. So dividing is how you determine your ratio for a geometric. So that r is the ratio, the d is the difference. Now, how do we determine what they are? Well, let's see here. We can add 3 or multiply by 2. Either way. 6 to 12. Adding 3 doesn't work, so it can't be arithmetic. Multiplying by 2 works. Multiplying by 2 works. So I'm multiplying by 2 every time. That's geometric. Here, adding 3, adding 5, adding 7. So you think I keep adding. However, I'm adding a different number. That's not arithmetic. That's neither. And I'll come back to that one in a second. Here, I'm adding a negative 6. And then I'm adding a negative 6. And then I'm adding a negative 6. Now, we want to think about it in terms of adding, not subtracting. So this is an arithmetic. And let me just talk about this middle one. When you see this pattern, add 3, add 5, add 7, add 9, add 11, you're adding the perfect squares. This always deals with, you're adding the odds. This always deals with the perfect squares. You think of the perfect squares as 1, 4, 9, 16, 25. And you can see this is just one more than each of those. So when you see that pattern, bells and whistles should go off in your head. Perfect squares, perfect squares, perfect squares. But we have 2 formulas now to help us determine the nth term. So if it's a arithmetic, we need to know this d, this difference. And if it's geometric, we need to know this r, this ratio. So let's see how we use these. If I want to find my 20th term, so to find my 20th term, I just substitute these in. My first term, let me go back a second. My first term, my t sub 1 is 3, plus 20 minus 1 times my difference. Well, my difference is what I add to get the next term. 21 minus 15, 15 minus 6. Now, to figure this out, I can just put this in my calculator. 3 plus 20 minus 1 times 6, and I get 117. If I want to find my 20th term of this geometric sequence, I use this formula. 3 times my r. What do I multiply to get my next term? 81 divided by 27 is 3. And then I have 20 minus 1. So if I put this into my calculator, I get a rather big number to get that. We only have formulas for arithmetic and geometric. If it's not one of those 2 types, we either have to try to figure out the formula or we don't know the formula, because these have nice formulas, which is why we use them so much. Now, if we want to find a formula just for the nth term, we use the same formula, but we just leave the n in the formula. So t sub n is just 3 plus n minus 1 minus 6. Now, I could multiply this out, and if I multiplied this out, I would get 6n minus 3. Those are 2 different ways of writing this sequence. You can see if I put 2 in there, 12 minus 3 is 9. For a geometric, I would get 3, and always put your r in parentheses. It just helps to make sure you don't make a mistake. So that's how to find the nth term of an arithmetic or geometric. I just use my formulas. But what if it's not arithmetic? What if it's not geometric? This becomes a little bit harder. This basically becomes, is your brain smart enough to figure out the pattern? And the way to do this is figure out what's the next term first. So let's see, I add 3, I add 5, I add 7, I add 9. That would be 26. Then I add 11. That would be 37. Then I add 13. That would be 50. Okay, so I'm figuring out the pattern. Now I got to figure out based on n. What I mean by when n, this is n is 1, This is n is 2, 3, 4, 5, 6, 7. So how can I get those numbers based on the n, knowing the pattern? And as I told you before, when you see this pattern, add 3, add 5, add 7. This deals with the perfect squares. So these problems become, is your brain smart enough to figure out the pattern? And 5 is 2 squared plus 1 is 5. 3 squared plus 1 is 10. So this is n squared plus 1. Let's go to the next one. What is the pattern? So first we figure out the pattern. This is 5 over 36, 6 over 49, 7 over 64. And now let's think about what the n is. This is my first term, my second term, my third term, my fourth term, my fifth term. So how can I determine the pattern? Can my brain figure out the pattern? Well, the top is just n. That's pretty easy. 1, 2, 3, 4, 5. The bottom are my perfect squares. But if I'm on 3, the bottom is 4 squared. If I'm on 4, the bottom is 5 squared. So I need n plus 1 to be my formula. So when they're not arithmetic and geometric, I can't just use these nice formulas. If they are, that's great. But if there's something else, I got to try to figure out what's the pattern to get my formula. All right, you are ready for the homework on sequences 1.